Hello everyone, this is the maker of Simple Tech Things. As I believe many of you might be encountering the subject SP a bit difficult, especially while writing the programs, understanding the logic behind it, and building one for the sums. So let us concentrate on one particular sum, the sine series. I'll show you the questions. These are the questions of the sine series, which can be asked in your MU exams, first year, second semesters, I believe. So we'll do the problem number 13. It says write a program to calculate the sine of an angle using the following series for x as the angle in radians, and then sine x equals to some equations has been given by them. Accept the angles from the user in degrees and display the results. So they have told us to accept the angles in degrees, and then while calculating this sine series, we need to do that in radians. So it is understood over here that we need to convert it into radians and then compute the following and give them the results. So the thing is, it is quite pretty much simple. It is not that hard. We can do this in 25-30 lines, I believe. Let's try and do it. I'll minimize this, and this ID's name is Dave C++. I just like it. You can use Turbo C++ too. And hash include stdio.h. This is the header files. The libraries hash include math.h. Now you don't need to write this header file hash include math.h into every program. And I'll let you know later on why I included this header file, and which library I wanted from that. I'll keep it pending. Okay, and it's on you if you want to write hash include conio.h or not. It's all up to you, because this header file consists only two things: the CLR, that is the clear screen function, and the get ch. Okay, so even if you don't write this, it's completely fine, because the ID, most of the this new IDs, they have pre-built into that. If you are writing this into the exam paper, make sure you write it, because most of teachers don't know this. What this header file consists of. They may even cut your marks. So for the sake of that, I'll just write it down over here, and then we'll start with the main function void main. Okay, so we need to accept the angles in degrees. So the user can enter the angles in degrees, in integers or in decimal points, anyhow he wants. So let us script the data type as float x. Okay, for degrees I'm considering the variable x. I'm declaring float x, and the other thing in the question we need to look at carefully is it's raised to 1, raised to 3, raised to 5, raised to 7, and so on. They all are the odd powers, so we can take that as int n. Okay, now let us get the input from the user. Printf, enter the angles. We just need one angle. Angle in degree. Scanf percentage f, because it's a float. Don't write d over there. It's a common mistake. Every one of us make that, especially when you're writing the exams. X. Now printf, enter the value of just ignore this. Value of power, or we'll say just n in our case. I'm talking about this, don't forget. X raised to 1, x raised to 3, raised to 5, 7, and so on, the odd powers. Okay, scanf percentage d because it's in integer form, I mean data type, and n. So we got the inputs. Now in the question it has been mentioned that except in degrees, but for the calculation part x has the angles in radians, we need that in radians. So I believe your maths isn't that weak enough. It's quite simple to convert it in radians. Just multiply it by 3.142 by 180. I'll show you this way. X equals to x into 3.142 by 180. Here you go. Now it has been x is in radian now. Okay, so it was quite pretty much simple. So now our x is in radians, we have converted it. Now we need a for loop. Now why do we need a for loop? It's self-explanatory that it's going up to n. We don't know, they haven't given us any limitations over here in the questions. So for that purpose we have to use a loop. We can use any of the loop, it's all on you. You can even use a while loop or a for loop, any loop. Okay, so I'm quite comfortable with this for loop for I equals to 3. Now you might be wondering why 3. Just wait a second, I'll tell you why 3. The condition should be I should be less than equals to n, because look at the question, it's 3, 5, 7, the same on the I mean in the power it's 3, 5, 7, so it should be till n. That's why the condition I less than equals to n, and it's a odd power, that's why I plus equals to 2. In the first iteration it would be like the value of I would be 3, in the second iteration it will be 5, 7, 9, etc, etc, and so on. So now we'll make it simple by just dividing, separating the parts. The numerator part, this x raised to 3, x raised to 5, x raised to 7, we will calculate this differently, and the denominator part 3 factorial, 5 factorial, and the factorial parts will calculate separately. So for that we'll declare the variables over here, and it should be in float. Now I don't need to say why float over here again, because it can be in point form too. Then means denominator and means numerator will even take a sum, because we need to separate all those terms now. We'll keep the value of sum as 0, because if we don't do this, sum will consist of some garbage values. And as we see here in the question, the denominator part is calculating the factorials of the numbers. So that's why whenever you calculate a factorial, always make sure you keep the first, the variable part of that variable or anything what you declare, name it, should be 1, or it's the same reason it will be containing any garbage values, and it won't give you the desired results. Then num equals 2. Now as I told you, why I have included the math.h into this programming, the coding, because here we need to use the power function. We want to use the power function, so power equals power bracket x comma I. Now what this x comma I means, it will simply, I'll write this in words. For example, in the first iteration, in the first loop, the value of I is 3, and the value of x, we have got that from angles in degrees, and we have converted it into radians over here. So for suppose we just suppose the value of x is 40 in radians, 40 raised to 3, it means this, this equation 40 raised to 3, and that value will be stored into num. So here we calculate the the upper part, this is a general term. Okay, let's get into the denominator part. The denominator, we just need to simply calculate the factorial of the n in our case. So it should be like I into I minus 1. Now what is this? I into I minus 1. So first suppose in the we need to find the factorial of 3, 5 or 7. And what's the factorial of 3? It's the factorial of 3 is 3 into 2 into 1, it's 6. So for suppose in the first iteration I is 3, so 3 into 3 minus 1, which is equals to 3 into 2, that is 6. We got our answer. So it is calculating properly, the logic is working. So we are done with the denominator part. Now simply we just need to divide both of them, num by den. So sum plus is equals to num by den, and so this is num by 10, it's done. But now we have left something, we have left this term, the only term x. So we have just calculated the series for the from this here, x is to 3 upon 3 factorial till n, but we left this term. So we just need to add this term before the loopings, before the for loop starts. Sum equals to x. So the value of x is already stored into the sum. That was the reason I started the value of I from 3 and not from 1, and then incremented it by 2 to get all the odd values only, and the condition I less than equals to n, as you can see in the question. And now we are encountering the another problem, that is the sign problem. First it is positive, negative, positive and negative, alternate signs. So we can solve this by taking a variable as sine and assign it to -1. Okay, so sine has been assigned to -1, and just put a bracket over here. Bracket into sine. So in the first iteration, the value of this first term x is already has been stored into the sine variable. Now we want the value of x raised to 3 upon 3 factorial, which has been calculated by this num and den, num by den. But while adding it into the sum, we want the sign negative over there in front of that. So the sign, this variable will do the same sign, which has already been assigned by -1. But another problem is that in the next iteration, when the value of I is equals to 5, we want a positive sign, and again a negative sign. So to solve this, just write this statement: sine is equals to sine into -1. So when it is done with the I equals to 3 part, the calculation part, it will multiply it by sine into -1. So -1 into -1 is 1. So when it's I equals to 5, it will consist sine, it will be having a positive number, a positive value, that is 1. Well, I hope you got the logic of the signs over here. So we are done with this, the computation part. The series has been developed, the general term for the series. So the only thing left is to print it on the console screen. The the answer is %f, because sum is in float, and I believe the answers will also be in the decimal points. All of the answers, 90%, I believe. Sum. So we are done here. Let's run it. We got an error. Yes, I just forgot to mention a this command line over here. Let's put the angles in degrees as 40 and enter the value of power of n is I'll put it 5. The answer is 0.649787. I believe this is perfectly right. You can check that on your Casio Kelsey. Okay, let's run it once again. No errors. Angle 57, that was my roll number. And this is 11. Answer is 0.861247. I hope you got the logic, and if you don't, just write it down in the comments. I'll try to solve it. And I hope I'm done with the video. And you can even mention which are the other problems you want me to solve. I'll make a video on that too, because I don't know what problems you guys are encountering. Well, thank you so much for watching.